Since the 90s, Hubble Space Telescope has been changing the way humanity sees the universe. Its images became iconic. The pillars of creation, the Carina Nebula, deep fields filled with thousands of galaxies. Some of the most famous space images ever taken. But then JWST launched, and suddenly those same parts of the universe started looking completely different. Hidden stars appeared. Structures inside nebulae became visible for the first time. Entire galaxies started emerging from regions that once looked almost empty. And honestly, some of the differences are hard to believe until you see them side by side. So in this video, we are going to compare some of the Hubble's most legendary images with what JWST showed us years later. The most recognizable image coming from Hubble are pillars of creation, captured back in 1995. Even today, it still looks mesmerizing. At the time, this image completely changed space photography. You've got these enormous towers of gas and dust stretching light years into space, with new stars actively forming inside them. And for decades, this was one of the clearest looks humanity had ever gotten into a stellar nursery. But then JWST looked at the same region, and suddenly the image became almost unrecognizable. Now you can see stars that were completely hidden before. The dust clouds looked thinner, deeper and more layered. Some parts that looked almost solid in the Hubble images suddenly became transparent. And this is where you really start understanding what JWST was built to do. Because unlike Hubble, JWST can see much deeper into infrared light, which means huge clouds of cosmic dust stop blocking the view, and the result feels less like a sharper image and more like an entirely new version of the universe. The next image is Carina Nebula, and honestly this is where JWST really started showing off. Just a little bit. The original Hubble image already looked incredible. You had these massive walls of gas and dust, young stars forming everywhere, and structures so large they almost hard to process properly. But when JWST looked at the same region, the entire nebula started feeling three-dimensional. You started noticing depth everywhere. There are layers hidden behind the layers of dust, tiny stars scattered across the background, and these detailed filaments running through the clouds. Some parts genuinely stop looking like a photograph and start looking like CGI. What you're looking at here is a giant stellar nursery roughly 7,500 light years away from Earth, where new stars are constantly being born inside those clouds of gas. And this is where infrared astronomy becomes completely ridiculous, because a lot of the stars inside the Carina Nebula were almost impossible to properly see through Hubble. The dust was simply blocking too much light. But JWST can cut through that dust, which suddenly exposes entire regions that were basically hidden before. This is one of those images where the longer you look at it, the more details you start to notice. The amount of stars is just bonkers. And now this is where the things start getting really interesting. Because nebulae are one thing, but seeing JWST look at actual planets in our solar system feels completely different. This planet needs no introduction. This is Jupiter, captured by Hubble. It looks amazing. You can clearly see the cloud bands, the storms, the atmosphere, even the great red spot standing out near the surface. For years, Hubble gave us some of the clearest views of Jupiter. But then JWST took a look, and suddenly Jupiter started looking almost alien. The first thing you notice is just how much more intense everything becomes. The auroras near the poles suddenly explode with detail. The atmosphere starts showing these deeper structures and turbulent patterns hidden inside these clouds. Even the rings become more visible. Honestly, this image is one of the best reminders that JWST wasn't just built to look at distant galaxies. It's also changing the way we see objects much closer to home. What makes this even crazier is that some of the glowing structures you are seeing here, they're not visible to human eyes. A lot of this detail only appears in infrared light. So in a way, JWST isn't just giving us sharper images, it's showing us parts of the universe we literally couldn't see before. And up next we have the Southern Ring Nebula. And this might be one of the biggest glow-ups in the entire video. The original Hubble image already gave us a pretty incredible look at this dying star surrounded by expanding shell of gas. You could clearly see the outer structure of the nebula, the colors, the shape, and for years this was one of the best views we had of it. But with JWST, the entire thing became way more detailed. Now you can see these enormous layers of gas stretching outward in every direction. almost like ripples exploding through space. The textures become sharper, the dust structures became clearer, and the amount of hidden detail is honestly ridiculous. And this is the part that really blew my mind. Right near the center of the nebula, JWST revealed a second star that was much harder to spot before. And that second star is probably what helped create the nebula in the first place. So the image didn't just become prettier, it's actually helped astronomers understand the system itself much better. And this is something you start noticing over and over again with JWST. A lot of these images are not just visual upgrades, they reveal in actual structures, stars, and features that were hidden before. Back in the 1990s, astronomers pointed Hubble toward what looked like a completely empty patch of space. There was basically nothing there, or at least that's what people thought. Then Hubble stared at the tiny region for days, and the result completely changed astronomy forever. And now, in front of you, you have one of the most important images in the history of astronomy. The Hubble Deep Field. Suddenly, that empty patch of darkness turned out to be filled with thousands of galaxies. Not stars, galaxies. Entire systems containing billions of stars each, all packed into this tiny little section of sky. And for years, this was one of the deepest views humanity had ever captured of the universe. Until July 2022. Suddenly, even more galaxies began appearing in the background. Some of them are so distant that we are seeing them as they existed not long after the universe itself formed. You can see distorted structures, ancient galaxies, and faint points of light that Hubble either couldn't properly detect or couldn't resolve clearly enough. And honestly, this image is one of the best examples of why JWST is such a massive leap forward. It's not just showing us beautiful pictures, it's allowing humanity to look further back in time than ever before. And now we have the Phantom Galaxy. And compared to some of the earlier images, this one feels a bit different straight away. Less chaotic and more elegant. The original Hubble image already gave us an amazing look at the spiral structure of this galaxy, especially those huge sweeping arms stretching outward from the center. Even by today's standards, it still looks beautiful. But when JWST zoomed in on the galaxy, suddenly insane amounts of hidden structures started coming to view. You can see those tiny filaments of dust running through the spiral arms, then stars forming regions scattered across the galaxy, and clusters of stars that barely stood out before. Even the core of the galaxy becomes dramatically more detailed. And this is where JWST's infrared capability starts becoming almost unfair. And lastly, this is where things start becoming difficult to fully process. Because all of these upgrades in detail, infrared imaging, and deep field observations eventually led JWST towards something astronomers have wanted for decades: the earliest galaxies ever observed. Some of these objects are so far away that their light began traveling across the universe more than 13 billion years ago, which means JWST isn't just looking deeper into space, it's literally looking further back in time. What surprised astronomers almost immediately was how many of these early galaxies started appearing in JWST data. Some of them already looked massive and surprisingly evolved at a stage of the universe where they probably shouldn't have had enough time to grow that large yet, which is part of the reason JWST became such a huge deal so quickly after launch. It wasn't just producing beautiful images, it was actively giving astronomers new problems to solve. And honestly, that might be the craziest part of all of this. After decades of Hubble completely transforming our understanding of the universe, JWST arrived and somehow made the universe feel mysterious all over again. If you enjoyed watching this video, feel free to subscribe to Spaceopedia for more space content like this. Thank you for watching, keep looking up.